Hi, hello. This is the front end for this LITMUS project. And first of all, we can see a screenshot of the website we have built. It shows how the infection cases develop over time in United States. What's more, once we have detected an event that indicates a coronavirus case has occurred, and from Twitter, it will display this event on this map. I will go into the details on these following presentations. You can also visit this website via transautonomy domain. For the deployment, the server I got was from Wattler and the domain I bought from GoDaddy. The front end was deployed using Apache and it only uses HTML, CSS, and JavaScript. For the back end, which uses the TensorFlow class and the Python Flask framework, I was able to build it using Docker. The communication between the front end and the back end were via the 5000 port in this server. Again, you can visit this website if you are interested. The source code is also pushed in my GitHub. For the First, let us talk about the data part in the front end. There are two data sources. One is from CDC, which is confirmed. Another one is from Twitter, which is unconfirmed. I have collected and pre-processed them using Python. After that, I loaded them via JavaScript files. You can see the sample structure of these two data. In the left side of my website, I have built a chart to see how the number of cases in United States increased over time. This was created using C3.js. The core part of the code was to sum over all states. In the right part about the map visualization, it is a little bit more difficult. First, we need to collect the information about the shape of the US states. Thankfully, this information is not very big, so we can store and display it using GeoJSON via JavaScript. There is also a sample about each feature of this GeoJSON data. Next, to make the website more user-friendly, I have added interaction and customized information. This was implemented via an event listener, which will monitor the mouse over event. Once the user moves the mouse to a state he is interested, that state will be highlighted. What's more, I also added a controller to update the information according to the selection of the user. You will be able to choose any state in United States and any date between March 1st and March 31. The core code in this part was this picture. It aims to update the coronavirus information in this map. There is a short video about this. If you can see how the time evolution of the COVID cases in United States. Finally, the most interesting part in this project is that it is able to display an event from Twitter. If the model we have built predicts this Twitter message is related to coronavirus, you can click on the Click Me button to retrieve a Twitter message from the server. Once the message is redeemed by our model to be valid, a marker will be added to this map. You can click on this marker to get into details of the Twitter message. Once you have visited all tweets in our server, the markers will be cleared. Again, there is a short video show how this works. By clicking the Click Me button, a Twitter message was retrieved, and this tweet was added to this map since it was deemed to be valid.
Now I'll introduce the whole framework for our LITMUS project. This is a framework for event detection, such as coronavirus disease. It incorporates with both probabilistic source and the collaborative source. This is the overall architecture of our project. We use Twitter as our probabilistic source and the CDC data as a collaborative source. We have a location detection model to detect the place names in the text. After the integration of both kinds of data, we use vectorization techniques to convert the text into vectors that is needed for the input layer of our neural network. We use convolutional neural network as our text classifier, and we use that to detect whether the event happens or not. And we post that event on the event map using design.javascript. There are two kinds of data source in our project. The first is the probabilistic source. It is generated mostly by social sciences such as Twitter and Facebook. It covers a wide range of area, contains a lot of details, and is much quicker than collaborative source. Collaborative source is generated most by official website. It is very accurate and trustworthy, but it costs higher than the probabilistic source. Also, it often provides an overview of the event rather than every details of it. For the data streamer, we use Twitter API to get our data for the probabilistic source. The first thing we need to do is to generate keywords for the tweet search. Thanks to our great TA, we get 31,000 tweets for February and 137,000 tweets for March. For the collaborative source, we use the CDC data. We get the data for everyday cases for each state. We write data parser to to process these two kinds of data. We use regular expression and Python CSV reader to read and process these data files. Since we need to post the event on the event mapper, we need to find out where exactly did the event happen. For this purpose, I write a location detector to detect the place names in a text. And there are different kinds of names in a text, such as a city name, a county name, and a street name. Since the unit of our location is state, I need to classify these different kinds of name into the state. To accomplish that purpose, I used Python geography library. It uses three techniques for this whole aim. First, you use the Python LTK for entity recognition, and it used the jellyfish for fuzzy text match, and it used the py country for country and region lookups. In this process, we use the techniques called name entity recognition. It is to classify names into the category of an entity. To transform our text into the input layer for the neural network, we need to vectorize this text. The first step is to vectorize each word in a sentence. For this purpose, I use a technique called word-to-vec. It means to use a vector to represent a word, and the word in a similar context have similar embeddings. Below is a graph that represents the vector space of a word. You can see that the distance of pork and beef is very close because they represent the raw material of food. and the distance between boiled and baked is also very low because they both represent how to make a food. And I used the Google News to train our model, and I used the Python JSON library to invoke relevant useful APIs. After we get the vector for each word, we then use a technique called sentence to vec to use a vector to represent a sentence. There are many ways to do it, but none of them is perfect. Either they cost too much or they are not very accurate. A straight way to do it is to calculate the average of each word vector in the sentence. Below is a code snippet of how I wrote this function. Next is to build the text classifier to detect whether the Twitter belongs to our event or not. I used the work vector as I mentioned before for the embedding layer, and I used the convolutional neural network for the text classification. Below is the graph that shows how the convolutional neural net works for the text classification task. Now it comes to our analysis part. First, I want to report that our classifier achieves accuracy of 76%, and I made some extra analysis on our dataset. Below is the graph that indicates the number of tweets for each state and the number of confirmed cases for each state. It shows that the number of tweets about coronavirus does not rise with the number of confirmed cases. It shows that the coronavirus gets people's attention at first, but not continues rest hit as it continues goes on. It rather corresponds to the law of news. You can see that as breaking news happens, all the people want to know the background and the news about it, but until it continues to happen, people just get used to it. The second extra analysis I made is the comparison between the number of tweets for each state and the number of confirmed cases for each state. You can see that the number of tweets about the coronavirus for each state does not have a very high correlation with the number of confirmed cases for each state. The California state has the most tweets about the coronavirus, but the New York state has the most confirmed cases. I think that the number of tweets only indicates that there are more people in that area like to post their feelings about this coronavirus disease. Here is a discussion. I have read more than 300 tweets for February 28th, but none of them report a case about COVID-19. Some of them talk about the corona extra beer, and some of them thought we should not worry too much about it. And most of the tweets talk about the users' feelings about the event rather than report that they get infected. I think the Twitter data is more appropriate for detecting an event, which means that to detect whether it happens or not, rather than calculate the specific number of cases. For the future works, first I think we can find a more accurate way to detect the location in the text. Currently, my algorithm runs more than an hour on my laptop to process one day's data. If you want to process months or even years of data, you need to prepare ahead of time. The second thing we can do is to propose a more accurate way to calculate the vector of a sentence. The NLP is still developing and there are no perfect way to convert a sentence into a vector. The third thing we can do is to write a better text classifier with the advanced deep learning technology. And the last thing is to discover more about the potential of the probabilistic source. I think it is a very promising research topic. Well, this is the presentation of our project. Thanks for your time.